Hi, my name is Patel. In the past few lessons on volume, we have seen that to work out the volume of right prisms, we need to know two things. Firstly, the shape of the base of the solid, and then the perpendicular height of the solid. In this lesson, we're going to look at how we can use that information to determine the volume of other right prisms. By the end of this lesson, you should be able to apply a formula to work out the volume of a right rectangular prism, a right triangular prism, and a right trapezoidal prism. Do you remember what the difference is between a right and an oblique prism? In a right prism, the lateral faces are always perpendicular to the bases. In an oblique prism, the lateral faces are not perpendicular to the bases. And do you remember what the formula is for the volume of a right rectangular prism? It is the area of the base, which is a rectangle, multiplied by the height. Since the area of a rectangle is length times breadth, the formula for the volume of a right rectangular prism is equal to length times breadth times height. Have a look at this model. Can you guess what this prism is called? The lateral sides are perpendicular to the base, so it's a right prism. But what kind of prism? Look at the shape of the bases. Do you remember that a prism is named according to its base? The base of this prism is triangular. So this is called a right triangular prism. Here we have a diagram of the wooden model of the right triangular prism. Let's see if we can use what we know about the formula for the volume of a right rectangular prism to find the formula for the volume of a right triangular prism. What do you think would change about the formula now that we have a triangular prism rather than a rectangular one? To find the volume of a right rectangular prism, we multiplied the area of the base by the height. That remains the same for all the right prisms. But the base is no longer a rectangle, it is now a triangle. So all we need to do is to change the formula for the area of the base from the formula for the area of a rectangle to the formula for the area of a triangle. In other words, the formula for the volume of a right triangular prism will be the area of the triangle, which is equal to half the base times height multiplied by our perpendicular height. Here I have a wedge of cheese. They are usually packed in groups of 12 and come in cylindrical containers. The shape of the wedge of cheese is very similar to that of the right triangular prism. The only difference is that the top of the wedge of cheese is a little bit rounded. But for our purposes, we can take it to be a right triangular prism. Now, what do you think the volume for this piece of cheese is? Could you estimate its volume in cubic centimeters? We have already measured it in the studio, and this is what we found. The height of the right triangular prism is 1 centimeter. The base of the triangle is 5.2 centimeters. And the perpendicular height from the base is 5.1 centimeters. Now we can substitute the values given in the diagram into the formula for the right triangular prism. So we have half multiplied by the base of the triangle, which is 5.2 centimeters, multiplied by the perpendicular height from the base, which is 5.1 centimeters. Multiplied by the height of the triangular prism, which is 1 centimeter, which equals 13.26 centimeters cubed. How close was your estimate to this? Since the container holds 12 of these wedges, we can say that the container holds approximately 12 times the volume of this wedge. So, 12 times 13.26 centimeters cubed is equal to 159.12 centimeters cubed. So now you know that when you buy a box of these cheese wedges, you're getting approximately 159 cubic centimeters of cheese. You can compare that to other pieces of cheese. Take, for example, this block of hard cheese. It's in the shape of a right rectangular prism. By applying the formula for the volume of a right rectangular prism, I have worked out that this piece of hard cheese has a volume of 11.4 centimeters times 8.9 centimeters times 2.5 centimeters. Which gives us 253.65 cubic centimeters. The interesting thing now would be to compare the difference in prices between the two items. Then I could be able to see which one is giving me better value for money. Now let's look at another right prism. What is the shape of the base of this prism? It is a trapezium. We call this prism a right trapezoidal prism. We can see that the prism has a height of 150 centimeters. We can also see the dimensions of the base trapezium. Its parallel sides measure 80 centimeters and 40 centimeters, and its perpendicular height is 50 centimeters. Do you remember the formula for area of a trapezium? It's half the perpendicular height times the sum of the two parallel sides. This is written in short as area of a trapezium equals half the perpendicular height, h, multiplied by the sum of the parallel sides, a and b. So working out the volume of this right trapezoidal prism should be quite easy now. See if you can do it with me. So we can say that the area of our trapezium is equal to half our perpendicular height, which is 50 centimeters, multiplied by the sum of our parallel sides, which are 80 centimeters plus 40 centimeters, which is equal to 3000 centimeters squared. Now let's substitute this area into our formula for volume. Since this is a right prism, the volume of our trapezoidal prism will be equal to the area of the base, which we found to be 3000 centimeters squared, multiplied by the height of the prism, which is 150 centimeters, which is equal to 450,000 centimeters cubed. It's time to recap what we've done today. In this lesson, we have seen how easy the area formula for the base shape, the dimensions of the base, and the height of the prism. We have worked out the following formulae already. Volume of a right rectangular prism is equal to the area of the rectangular base times the height of the prism, which is equal to length times breadth times height. Volume of a right triangular prism is equal to the area of the triangular base times the height of the prism, which is equal to half base times height times the height of the prism. Volume of a right trapezoidal prism is equal to the area of the trapezoidal base times the height of the prism, which is equal to half the perpendicular height multiplied by the sum of the two parallel sides, multiplied by the height of the prism. Here's your task for today. Look at this diagram. It shows a wooden right rectangular prism with a right triangular prism cut out of it, leaving a hole in the wood. What is the volume of the piece of wood in this picture? By now I'm sure you have a good sense of how to distinguish between different types of prisms. As you've seen, it's really easy and fun to find their volumes. Try it at home with objects around your room, and until then, bye.